When you run an at-risk simulation, at-risk allows you to filter either inputs or outputs in several ways. Probably the most frequently used filter is to filter out extreme values in one or both tails of a distribution, but this is only one of many possibilities. You can create filters from the Define Filters button on the at-risk ribbon, or you can do it with the Filter button on several at-risk report windows. I will illustrate the possibilities on the model of discounted cash flows shown here. This model was adapted from one of the at-risk example files. The uncertain inputs appear in green font, and the single at-risk output, NPV, appears in maroon font. The Define Filters button lets you restrict input or output values by conditions you impose. As you can see, this button is disabled until you run a simulation. So the first step is to run the simulation. The distribution of NPV without any filters is shown here. It will be useful to keep this graph in mind as filters are added. For example, around 250,000 for the 95th percentile. Then you will see the effects of the filters. The Define Filters button provides several options, two of which are illustrated here. First, you can apply a filter to an input. I will do it here. There are three options. It's either off, standard, or iteration. I will use iteration. I will make the percentiles the 25th and the 75th. And I will apply this filter. This filter restricts the annual revenue growth rate to be between its 25th and 75th percentiles. Remember that the simulation has already been run, so some of the iterations had growth rates beyond these limits. However, when you click Apply and then browse the NPV result, you will see results only from the iterations that satisfy the filter conditions. In other words, you will see the output distribution only for the restricted range of this input. However, to get this behavior, you have to select iteration as the type. Here is the filter distribution of NPV. It turns out that the annual revenue growth rate has a large effect on NPV, so by restricting the values of this input to a narrower range, the NPV is also restricted to a much narrower range. For example, the 95th percentile was originally about 250,000. Now it is only slightly above 100,000. If you change the type of filter for this input from iteration to standard, the effect is less interesting. Now only the graph of the input is affected, as you see here. The graph of the NPV output reverts back to its original form. The second use of the Define Filters button is to apply a filter to an output. This can be used in conjunction with or instead of a filter on an input. Here I will use the latter option. So the first step is to clear the filter on the input. Now I will create a filter on the output, NPV. Its type can be either standard or iteration. They both have the same effect. And I will restrict it to be between the 10th and the 90th percentile. Now I will browse NPV. And I see only a restricted range of values, the middle 80% of the NPVs. An alternative way to apply the same types of filters is through the Filter button at the bottom of several at-risk results windows. For example, to apply a filter to an input, you can select the input cell, click Browse Results, Click the Filter button, and you get the same options as before. You can also apply a filter to an output cell in exactly the same way. To clear any or all filters, you can click the Define Filter button, highlight the filters you want to clear, click the Clear Filters button, and click the Apply button. Now there are no filters.